So thus far in calculus, you've learned how to take the limits as x is approaching a finite value. For example, the limit as x approaches 4 of some function f of x. But today we're going to be talking about what happens when x is approaching an infinite value. For example, the limit as x approaches infinity of f of x. And so what is this asking for? What does that mean as x is approaching an infinite value? What this limit is asking for is, as x takes on larger and larger and larger values, what value is it going to be approaching for f of x? And so this is really a graphical question. This is really well represented as a graph. So let's see, on this set of axes, let's make this the x-axis, and this is the f of x axis. And so let's say the function looks something like this. And so we have a horizontal asymptote right here at like value c. So let's take the limit as x takes on larger and larger and larger values. So let's look right here. This is going to be what this is asking for right here, as x is approaching larger and larger and larger and larger values this way. Well, f of x is going to be also taking on larger and larger and larger and larger and larger values. So as x is approaching infinity, so is f of x. So the answer to this limit would be infinity, or since infinity isn't a number, it would technically be does not exist. But if this is a multiple choice question and one of the choices for this question was infinity and does not exist was not an answer, then your answer would be infinity. But that's not the only limit we can take as x is approaching infinity. Remember, we can also do the limit as x approaches negative infinity. A negative infinity isn't a value, but it's just asking for, okay, as x becomes increasingly more and more negative, as it increases in larger and larger values to the left, so really smaller and smaller values of f of x, well, what's it going to be approaching? So let's look right here. So right here is x approaching smaller and smaller and smaller, or more negative values, I guess would be more correct to say. F of x is going to be approaching very much so to this horizontal asymptote right here, which is at the value c. And it's never going to hit the value c. But remember, we're getting so small, we're using x values so negative, so much to the left, that it's going to be approaching c. And that's really what this question is looking for. And so that would be your answer for this. So graphically, this is much easier to, comprehend. But let's say you're given an algebraic question. I have one written down all the way down here. The limit as x approaches infinity of x squared minus x minus 6 all over 3x squared plus 1. And so looking at this, going from the graph, like a simple graph, this can be a bit overwhelming. So let's try and think about this more logically. As x is approaching larger and larger and larger and larger values, wouldn't these values right here become insignificant in a way? Because these values, this x squared and this 3x squared, they're going to be the largest numbers. And as x is growing very much so, it's infinitely growing, these are going to become infinitely small. These numbers right here are going to become infinitely small compared to these values. So really, we could use something called an end behavior model, which is just the leading term of the numerator over the leading term of the denominator, which would simplify to the limit as x approaches infinity of x squared over 3x squared. And so you can simplify the x squared out, so you can just cancel out these x squared values. And now you have the limit as x approaches infinity of 1/3. And so now there's no x. So the answer to this limit is just 1/3, since it's a constant. But if you want a more formal way of doing this, let's say this can be a little too, logical, maybe not logical, but more so away from formal standards of like algebra, there is another alternative. So we'll take a look at that. Now this method takes a little bit longer to solve for, but it's technically more formal, I guess you could say, but you get the same answer anyway, so I really see no point in using the end behavior model. But let's do this for the sake of, knowing it and getting a better understanding. That looks like an 8. Let's change that. So we have the limit is x squared minus x minus 6, this rational function right here. So for the formal way says, okay, let's multiply the numerator and the denominator by the reciprocal of the largest power of x. And so that's kind of difficult to explain in words, but it's basically asking for, okay, what's the greatest power overall? Which x has the greatest power overall? And that would be x squared, because the only other x there that has a greater power is x to the first, which is less than x to the x squared. So we're going to multiply this by 1 over x squared on the numerator and 1 over x squared in the denominator. And so this whole thing right here, it just simplifies to 1, because it's just one number over itself. So that's just going to simplify to 1. So we're not really changing the function, we're just sort of simplifying it. So let's do x squared over x squared minus x over x squared minus 6 over x squared, and that entire thing over 3x squared over x squared plus 1 over x squared, and then oopsies, the limit as x approaches infinity. And so now we can simplify some things. So this would simplify to 1, and this would simplify to 3. But what about these values right here? Well, remember how when we were looking at the end behavior models, these became so small that they became insignificant? Well, the same thing is going to happen here, because think about it. These values right here, as x approaches infinity, these denominators are going to become increasingly larger. These values right here become increasingly larger compared to the top values. And so what that means is that they're going to be, the entire number, the fraction as a whole, is just going to be getting infinitely small. It's going to be getting so small, and we're constantly approaching larger and larger values. So these are all just going to approach 0. So we can just cross out these entirely, and we get the same exact expression. The limit as x approaches infinity of 1/3, which again equals 1/3. So with the end behavior model, which takes half the time, and the formal method of looking at this, you get the same answer.